Now we're talking about how we get crystals. Now, in all the samples we just passed around, they all have well-defined crystals. Guys, stop talking, please. But I want you to compare these two minerals. We've already seen this one before. This is olivine. This is something new for most of you guys. It's kind of neat. What do you notice about the size of the crystals? You guys notice?
That one's bigger. That one's flat.
Okay. So this one's smoother than this. We have big crystals versus really small crystals, or almost no crystals, right? So we always get well-defined crystals. So what's the limitation? Why does this one get big crystals and this one only gets little crystals? What's the difference? There's two things that minerals need in order to grow crystals. Two things. Take the fish tank in the back of the room. Right now, I have 14 fish in that tank. What if I only had one fish in that 45-gallon tank? What would happen to that fish?
It would get longer. It would get bigger and bigger and bigger until it
Say again?
would get bigger and bigger and bigger.
It gets bigger and bigger and bigger until it can't grow anymore, right? Because basically a fish will grow to the size of their environment, correct? Okay? Minerals do exactly the same thing. Minerals will grow to the size of their environment. If you're in a very restricted space, you're not going to get well-defined crystals. So we clearly had more space for these crystals to grow than we did for these. Now there's another thing that's required for crystals to grow. Not just space, but lots of time. So given enough time to cool, we can get very, very large crystals. An example of that, now we'll pass it on too. So given enough time and enough space, we can get large crystals that actually start to grow. So again, the two things crystals need, time and space. Pass these around as well. Now, question is, how? Not only do we need time and space, but how do they form? How do minerals actually start to crystallize? Well, we had two forms up here. One from magma, the other one's out of solution. All right, so again, we're talking about magma. Think about magma as this molten soup of a bunch of minerals together. And what I want you to think about is, again, space and time. When magma comes out on the surface, is it warmer on the surface of the Earth or warmer in the underneath the Earth? It's underneath. So that means it's going to take the magma much longer to cool underground than it does above ground. Is that correct?
Yes.
Okay. Okay. So, since it takes less time to cool on the surface, we actually get very smooth rocks that form, where we have very, very small crystalline structures, because it doesn't take very long to grow. They don't have the time to actually form the crystals. So this is like obsidian. So this is where we get that from. However, given enough time, we can get very sharp and very large crystals that grow inside the rock. So that's one of the ways we actually get a lot of these minerals, is they form from the cooling of magma. One of the other ways we can get rocks that form, or minerals that form, is actually from solution. Kind of like what we're working on over here. That was supposed to happen over the weekend. So, I have my hand right here, a little hand warmer.
And we have those too.
Oh my
So we're talking about why this works. Good. Then tell us. Oh, okay. All right. So basically there's this solution inside here. That's kind of a cloudy looking solution, not very clear. And there's actually minerals that are dissolved in here. And this is where I went wrong on Friday when I made my solution. I made it saturated, but I didn't make it super saturated. I didn't know what the difference is. Has ever heard of that difference before? Okay, how many of you guys like sweet tea?
Right here.
Depends.
Okay, how many of you guys ever made your own sweet tea?
Depends what kind.
Okay, tell me how you make it.
I know.
All right, go ahead, Anna.
Okay, you put the water in the jug, and then we take 6 tea bags, and we put it in there. And then, wait, first we put hot water in there. And then sugar. And then we dissolve all the sugar. And then we put cold water, fill it all the way up, rest of it, and then we put the tea bag.
Yes.
How many of you guys have done where you had to sit outside for every day?
My grandma has.
Now, I want to talk about why that is. Water, guys, hush. The hotter water gets, the more it can dissolve. That's kind of why we actually take hot showers. Not just because it actually feels good, it kind of wakes you up in the morning. But it actually does it so that all that oils and stuff on your skin, the hotter the water is, the more it dissolves. It actually literally dissolves that stuff off your skin. That's the whole point. If you ever try to do dishes with cold water, you probably notice that most of the food's still on the dishes. Okay? But doing it in hot water, a lot of the food just comes right off. Okay? And that's because the hotter water is, the more it can dissolve. So, if I have room water, or room temperature water, and I dissolve some sugar in it, and I keep pouring in more sugar, and also there's sugar crystals left on the bottom, that means I've reached my saturation point. I've reached the point at which the water can no longer dissolve any more of the sugar at that temperature. That makes sense?
No.
So then the way that I want it to dissolve more sugar, to actually get to the sweet point, not just to, basically that's how you get super sweet or super saturated, is you warm the water up. And then it can actually dissolve more of that sugar. And so that's what we're going to do here. So in here, we have a little bit of a mineral. As soon as I push the button, you guys see that happening?
Wait, what's going on?
There's a button at the bottom.
And it actually releases this crystalline structure. And I'm going to pass this around for you guys to actually look at it and feel that heat. It's an exothermic reaction. It's basically sodium hydroxide solution. And by pushing that button, it gave a surface for that mineral to grow. And then immediately it takes off. So the other thing to note about supersaturated solutions, focus please. The other issue with the supersaturated solutions is that they are very unstable. So they easily crystallize with supersaturated solutions. Now what's kind of cool about it, you guys notice that I have boiling water up here in the front? So in order to get those minerals to dissolve away, what do I need to do?
Drop it in the hole.
I need to increase that temperature of the water inside that packet, and then immediately we'll start to dissolve those minerals. Okay, that's why I have the boiling water. No, I just keep them that so the crystallized, put it back in boiling water, dissolve those minerals. Top of the coin, and there you go. Yeah, try not to push on that too much. I should sit down. I don't know where you're going.
Why don't you come here?
Wait, how long is
I said cycle.
No.
All right, so we talked about how we get a solution. Now I want to keep